Hello and welcome to my second project with AppZiva. So I'm going to try to keep this video a little bit shorter than my last one, so I'm going to dive right in to my second project here. This project focuses on improving customer engagement in the banking sector for a call center for the client who is a bank, and they are working on a campaign to sign up their customers for a term deposit savings account plan that they have. And the goal of this project is to predict the likelihood that a call will lead to a successful subscription for the term deposit account, and also to identify some of the key drivers and customer types that influence whether somebody is likely to sign up or to not sign up for the term deposit savings plan. To tackle this problem, I broke the project into three different parts. The initial exploratory data analysis, a model benchmarking part where I got some benchmarks of different models on the data frames I plan on using. And then the final part is building the two model AI pipeline. And for the interest of time, I'm going to skip to the last part, building the AI pipeline. If you're interested in learning more about the other two parts, you can check out the link below. So the first thing I did was to build my DF demographic uh, data set, and this data set is a data set that has only the demographic features in it, along with the financial features. And the purpose of this data set is to create a model that will predict the type of person from the data set that might sign up for the term deposit account. Then I also created a different data set called the DF campaign data set. And this model that we will train on DF campaign data set will be a model based only in campaign features that the call center has already collected data on. And so the purpose of this model is to create a model that can predict who are the best people to call from the data set based on the past interactions of the call center campaign. So now we get to the fun part where we get to implement the two-layer predictive pipeline that I've been talking about. After all of the model testing, I landed on random forest classifier as one of the best classifiers to use. Um, and so we prepare our DF demographic um, data frame. And to use a random forest classifier, we need all numeric values. So we encode the binary columns from yes and no to zeros and ones. We do one hot encoding for some of the categorical values. We do some ordinal encoding for education and ordinal encoding for the months of the year to create this data frame here that has all numerical values in it, so we can begin to train our DF demographic model. We then train a model, and we use SMOTE, S-M-O-T-E, because we have the imbalanced target variable y to create some synthetic data to balance out our target variable. And we then print out the multiple metrics, the AUC, the recall, precision, F1, and accuracy. We use cross-validation with 5 folds, and then we create the model. So for this model, we created a random forest classifier that has a recall of 0.91, so 91% of the customers who actually signed up for the term deposit account are identified by this model. If we look at the feature importance, balance is the most important feature. Contact unknown was also an important feature, which is interesting. The age of the person is an important feature, whether or not they were married, whether or not they have a housing loan, uh, blue collar jobs and technician jobs were an important feature to decide. And so was whether they are married or whether they are single or not was also highly rated. Here's the confusion matrix for this model. It has 6,836 true negatives, 585 false positives, 496 false negatives. This is the most important value in terms of this project. It is customers who actually signed up but were missed. So in reality, we would like to try to limit as many of these false negatives as possible in this program so that we don't miss any people that might want to sign up. And then there are 80 through 83 true positives for this model on the test set. Using this model, we can create a new predictive feature. We can add a new feature to the DF demographic data frame. And we can use the predict probability function to do that. And that will add a feature for every customer in the data frame that is a percentage of how likely they are to be the type of customer based on demographic and financial data to sign up for the term deposit account. So here you can see that I'm adding a new sign up probability feature to the data set. And you can see some of the values here that are the predictive values for each of the type of people in the data set. Here is a quick kind of distribution of how those values are spread across the entire data set. And we can see that the mean of this data set is about 0.15, which is pretty low. On average, most of the people scored 0.15. The 25% quartile is 0.03, so 25% of the people scored 0.03 or less. 50% of the people scored 0.079 or less, and 75% of the people scored 0.19 or less on this sign up probability. So most people in the data set score pretty low for this layer one sign up probability. Although the max value was 0.99 and the min value is 0.0004. So we have probabilities for people in this data set that range from very, very low to also very, very high. Now we can use this probability feature that we created to create some targeted lists. And to do this, I made a group of people that have already signed up, people that we know have signed up, and then I got the percentage for this number, a threshold value for this number. So of the group that we know have already signed up, I found the number that the top 90% for this feature, the threshold value for this feature of the top 90% of people that have signed up, the top 50% of the people that have signed up, and the top 20%. The top 90% have a threshold value of 0.14 or more. The top 50% have a threshold value of 0.37 or more, and the top 20% have a threshold value of 0.68 or more. We can then use those thresholds to make filtered lists of the people that have not yet signed up. So here I am creating some filtered lists of people that have not yet signed up, and we can look at how many people are in those lists. So using the threshold value of the top 90% that have signed up, we can make a list of people that haven't signed up. That is 10,447 people. For the top 50% threshold, we have 3,200 people, and the top 20%, we have 789 people. We can now prepare some of these lists to be used on the next layer in the pipeline. So here I'm just creating new data frames that we're going to feed into the layer 2 pipeline. They will have all of the campaign features, none of the demographic and financial features, but we're going to add also the sign up probability from layer one. So we have day, month, duration, campaign, which are all campaign features. And we have the addition of our sign up probability from layer one. We then create the entire data frame that has those features for training the layer two model. Again, it's day, month, duration, campaign, and sign up probability. We can train a model for the campaign model using this data frame. Again, we use SMOTE, S-M-O-T-E, to balance the Y variable, and we train a model and get the metrics, AUC, recall, precision, F1, and accuracy. And here we can see, after creating this model and looking at the test set, that the recall is 0.9941, very, very high. So using the feature that we created to train a model seemed to be a very good predictor of who's going to sign up and who's not going to sign up. So looking at the feature importance for this model, that seems to be true. Sign up probability was the highest rated feature. And then after that was um, the duration feature. Here is just a quick look at the confusion matrix for this model. We had 7,085 true negatives, 336 false positives, 391 false negatives, and 188 true positives. So slightly better than the layer one results. We can then use this model to add a layer two sign up probability feature to our process data sets. So here I'm just adding a layer two feature to the filtered data sets that we created earlier. And you can see that now we have these data frames with day, month, duration, campaign, sign up probability, and layer two sign up probability. And then I just wanted to go back and recreate the data as it was originally. So I reverse some of the encoding that we've done, reverse the one hot encoding and the ordinal encoding back from numerical values back to their categorical values, and recreate these filtered lists with all of the original data features that the raw data came with. So now we have a two-layer pipeline that helps us predict which customers in the data set are likely to sign up for the term deposit. And I just quickly wanted to go over some of the graphs that I made in the results. We have the three levels of targeted lists. With the most broad list, you can see that the level 2 probabilities range from 0.1 all the way up to 1. For the middle level targeted list, the probabilities that they will sign up range from 0.3 to 1, and the most targeted list, the probabilities in that list for layer 2 model range from 0.6 to 0.1. I made some histograms here with that are colored according to the percentage of layer 2 probability. This one is for the job categories, and we can see that some of the jobs that stick out are retired, blue collar, and student. Stick out as categories that have high percentages of people likely to sign up. We have education. This category is a little bit mixed from list to list. It seems a little bit random. The contact categories in general, people that have unknown contact for the higher probability lists have a slightly higher probability of signing up. In the low probability list, the telephone contact was a bit higher. In the age graphs here, we can see that the older people in the data set have a higher tendency to sign up for the savings account And there's a little bit of a peak for the lower ages as well. And then the middle ages in the data set tend to sign up less often. For the day plots, we can see that across the board, people are more likely to sign up at the beginning of the month when they are asked. So, calling people at the beginning of the month is probably a good idea. For the month of the year, we can see there are some general trends here. Um, People seem to be more likely to want to save in February, March, and April across all three lists. There is a large peak at the end of the year for um, the least targeted list in December. There's a large peak in October at the end of the year for the middle targeted list. And for the most targeted list, there is a peak in June where that group of people is most likely to sign up. Here we have the duration graphs, and these are remarkably similar across all three lists. And it says that the longer the last call was to any of the customers in the data frame, in the database, the more likely they are to sign up. So a long call duration means they are more interested in signing up. Here we have the campaign features, and we can see that the less calls that you've made to anybody in the database, the more likely they are to sign up. So if you've made less calls and the last call had a high duration, they're probably likely to sign up. And then after making those graphs and looking at everything, I wanted to calculate how much time would be saved by using these lists. So I did my best to calculate the amount of time that you would save, at least on the last using the duration of the last call. And we can see that if we use the full data set, the last call duration is 283 hours. If we use the most broadest list with the 90% threshold of people that actually have signed up, it would be 739 hours, saving 73% of the time that you will spend calling people. If we use the middle targeted list, it would be 226 hours, saving 92% of the time that you would spend calling everybody in the database. And if we use the most targeted list, it would be 55 hours, and you would save 98% of the time that you would normally spend calling everybody in the database. So that's kind of it for this project. I have a few recommendations and for moving forward with the project. And if you want to check those out, you can head down to the link below. I have a Medium article I wrote about this project. And otherwise, this was a fun project, and it was really interesting to get inside some of the call center data. And I'm very much looking forward to my next project with AppZiva.